Let's see some more examples based on integration by substitution. Substitution is a very important and useful approach. It can reduce any integral into a simple integral wherever applicable. Like in this example 1, if we substitute the value of x as equal to t raised to 6, if we put x equals t raised to 6, and if I differentiate, I'll get dx equal to. Now if I make these substitutions in the original given integral, this is what we get. Now I can cancel out t square, which is going to give me this expression. Now you can write this as t cube plus 1 minus 1, and then you split the integral. Okay, rub a little portion and solve further. Now this integral I am going to split into two parts, t cube plus 1 divided by t plus 1. This is how I have split it into two parts. Okay, now you can use the formula for a cube plus b cube over here and write like this. So this is how the integral has reduced to a very simple expression. You can easily integrate this part. Okay, similarly, as this is a linear function in t, its integral would be log of t plus 1 plus c. This can be written like this. Now we'll put back t in terms of x. We assumed x is equal to t raised to 6. So t can be written as x raised to 1 by 6, or t square can be written as x raised to 1 by 3, t cube can be written as x raised to 1 by 2. Making these substitutions back here, this is how the final answer should be. Okay, let's see another example. Here, if you put x equals t to the power 4 and differentiate, now I'll make these substitutions in the original integral. In place of x you write t to the power 4, in place of dx you write 4t cube dt. This is what we get. Okay, now we can make another substitution to make it even simpler. If I put this 1 plus t cube, which is in the denominator, equal to z, and differentiate, which means now if I make these substitutions, this integral should now become, we get z here, dt, t square dt could be replaced with 1 by 3 dz, and this t cube could be written as z minus 1, and 4 stays as such. So it should now be equal to 4 by 3 z minus 1 by z dz, which I could write as 4 by 3 dz as first integral and this as the second integral. Okay, so 4 by 3 z minus 4 by 3 log of z should be the answer, but we need to change the variable back to t and then to x. So let's do that. I'll write here z is equal to 1 plus t cube. I put back this is what we get. Now we'll put back t in terms of x. If you remember, we assumed x as t to the power 4, so x raised to 1 by 4 would be equal to t, and x raised to 3 by 4 can be taken as t cube. Make the substitution. T cube would be x raised to 3 by 4. Okay, so this is what we'll get as a final answer. Okay, let's see another example. Okay, let's see another example. This is a given integral which can be written in this form. Okay, here if you put x as t to the power 6 and then dx as, making these substitutions in the integral, we should be getting t to the power 3 and similarly t square in place of dx. You put this. Now this can be written as and right here t square being common factor, we can cancel it out. I'll write like this. I'll split the integral into two parts. Now t to the power 6 minus 1 divided by t minus 1 is this is your first integral, while the second integral is this. You can easily integrate. This is what we'll get after integration. Now we'll have to substitute t back in terms of x. Initially we assumed x is t to the power 6, so we'll make the substitution. This should be the final answer to the question. Okay, let's see another question. Okay, let's see this question. Over here it seems 1 minus 6 raised to 23, that expansion could be huge, so it's better to make a substitution. If I put 1 minus 6 equal to t and differentiate, now I'll make the substitution. The value of x can be written as 1 minus t from here. Make the substitution here. Okay, that gives me t to the power 23 minus t to the power 24 into minus dt. So I can rewrite like this, which should be easy to integrate. Okay, now you'll make the substitution back in terms of x. The value of t being 1 minus x. If I make a substitution, so integral now becomes okay. This is the answer to the question. Okay, let's see another example. This is tan theta to the power n into secant square theta d theta. So if you put tan theta equal to t, then secant square theta d theta should be equal to dt. Make the substitutions over here. This becomes a very simple integral. Answer would be t to the power n plus 1 divided by n plus 1. Now put back the value of t. Tan theta raised to n plus 1 divided by n plus 1 plus c. This is the final answer. That was a simple one. Let's see another question. In this question, if you put x equal to sine t, see, whenever you have root of 1 minus x square, then x equal to sine t, x equal to cosine t are useful substitutions in such expressions. So like here, I am going to put x equal to sine t and differentiate to get dx equal to cos t dt. Make these substitutions here. This is sine square t, dx would be cosine t dt. Over here I write 1 minus sine square t. Now this could be rewritten as cos square t with the help of identity. I hope everyone knows that. Okay. Cos t cancels, so you're left with sine square t to be integrated. Okay, now I'll write further. So your integral now is reduced to sine square t. Sine square t could be written as 1 minus cos 2t divided by 2. Okay, so this is your first integral and this is your second integral. This would be t by 2 and over here you get sine 2t by 4 plus c. Sine 2t could be written as 2 sine t cos t. So t by 2, this is what we have got. Now I'll have to put back t in terms of x. So your original substitution was x equal to sine t, which means cosine t would be equal to root of 1 minus x square. Making these substitutions, your integral should now become sine inverse x divided by 2. Sine t is x and cosine t is root 1 minus x. This should be the answer to the question. Okay, this is the next example. What I'll do is I'll multiply and divide by x to get this. Now why I am doing this is because if I put x square equal to t, then this x dx could be written as half dt. So that substitution becomes easier over here. I can replace x dx with half dt and put x square equal to t. So this is your integral now. Now this is a simple expression. The integral of this is secant inverse t. Now I put back the value of t. T is x square. This would be the answer to the question.